Hello, guys. We are back.
Back at it.
So, hey, we've got just the converse rules of parallelograms. So now it's the idea of if it's this, then it's this, instead of the other way around. So, I mean, it's real easy. It's just remember, in order to be a definition in geometry, it's got to be true forward and backwards. So that's just what they're doing here.
Yeah, we're not making a major jump today.
No. So if you understood the other day, you're going to get this. Not really that different. So basically, this one says we can know something's a parallelogram if the opposite sides of a quadrilateral are congruent. Then it's a parallelogram. And so that the other way it was before is in a parallelogram, opposite sides are congruent. So now if you just have a quadrilateral where opposite sides are congruent, well, then you have a parallelogram.
Yep.
And then the other way is if both pairs of opposite angles are congruent, then you can also assume that it's a parallelogram. So now if they just give you angles, you can decide what shape it is based on that fact. Or if you got a quadrilateral with sides that are congruent on opposites, you can make a decision based about that. I mean, it's I don't know how else to say it to make it any easier.
No, just backwards is all.
Yeah, just backwards.
Just based on what you're given.
Let's just look at a problem here. So basically this says, is this shape a parallelogram, and then by what theorem? So if I look at this, I see that the acute angle in the upper left corner is 65, the acute angle in the bottom right corner is 65, and then the obtuse angle in the upper right corner is 115, and the other obtuse angle in the lower left corner is 115. So I have opposite angles that are congruent, and so therefore I have a parallelogram.
Yep.
I mean, it's really easy to see, guys. I mean, just slow down, use some common sense, and you can get it. Yes, both pairs of opposite angles are congruent. And so then we have this one, and now we're focusing in on the sides. So the top side is 7, the bottom side is also 7, so those are congruent, so there's half of it. And then the left side of the parallelogram is 5 inches, and the right side of the shape, is also 5 inches. So once again, yes, it's a parallelogram because opposite sides are congruent. And there it is. I mean, just look at it for a moment, and it kind of makes sense. I mean, it really does.
You just have to be careful, make sure you have both.
Yeah, both. Key.
That's both pairs of angles or both pairs of sides.
Yeah, it's got to be that way, guys. So make sure it's all the information is present.
Yep. Okay. And then we're just going to keep going with the ones that we had in the last video. And so if one pair, actually this one's new.
Yeah.
If one pair of opposite sides is both congruent and parallel, that forces the other pair to also be that way. Okay, and so then it would go into one of the other theorems. But as long as one pair of opposite sides are congruent, so same length, and parallel to each other, that forces the shape to be a parallelogram. Okay, and then I believe this is our last theorem for this section. If the diagonals bisect each other in a quadrilateral, then it has to be a parallelogram. And we're going to use that one a lot later.
Yeah.
If the diagonals do bisect each other, that forces the quadrilateral to be a parallelogram specifically. Okay, so 2 new theorems there. So same type of questions. Is this a parallelogram, and by what theorem? So we're looking at one pair of opposite sides, the top and the bottom of this shape. Remember, the little red arrow means that they are parallel, okay, and they're both 30 meters long, and so they are congruent. So one pair of opposite sides is parallel and congruent. That forces the other 2 sides to be the same, parallel and congruent. Therefore, this has to be a parallelogram. So yes, it is a parallelogram because one pair of opposite sides is both parallel and congruent. I don't know why that says both pairs.
Now, Kevin, if let's say we were given that the top piece was 30 and the bottom piece was 30, but then the left side and the right side were parallel, could we assume that it was a parallelogram?
No.
Okay, so be careful there, guys. Make sure you're talking the same side here.
Yep.
That's parallel and congruent.
Yeah.
Same sides, or that has to, both pieces of information have to be on those parallel sides. So.
Yeah. I don't know why that green box says both pairs. That should say one pair of opposite sides is both parallel and congruent is what it should say.
Oh, okay. I didn't see that.
Yeah. Okay. And then for what value of x makes this a parallelogram? Well, we're looking at if the diagonals bisect each other is what would make this a parallelogram. And so we know one of them is bisected because of the 2 hash marks. And so that would force the other 2 pieces, the 2x and the 10 minus 3x, if those 2 pieces are equal to each other, then PM would also be bisected. So if we're looking for a value that would make it bisected, we would set those equal to each other. So if we set 2x equal to 10 minus 3x, move the 3x to the other side, or add 3x to both sides, we get 5x is equal to 10. And so if we divide both sides by 5, we would get x is equal to 2. And so if x equals 2, then that diagonal MP would then be bisected. And so both would be bisected. So by that last theorem up on top, both diagonals being bisected means that that has to be a parallelogram. All right?
All right, hey. My advice to you guys is write this down. Pause it now and write all of this down clearly on one sheet of paper. I mean, ways to prove quadrilateral is a parallelogram. Look, there's 5 of them. You got to know all 5 here, guys. And this will be a lifesaver for you on a test or something like that. If you practice this, you got them all right there. These are the things that make a parallelogram. So here, ways to prove a quadrilateral is a parallelogram. Number 1, show both pairs of opposite sides are parallel. Okay, that's the definition of a parallelogram. Number 2, show both pairs of opposite sides are congruent, like they show in the picture on the right. Number 3, show both pairs of opposite angles are congruent, like they show you there on the picture on the right. Number 4, show one pair of opposite sides are congruent and parallel, like the picture on the right. And then number 5, show the diagonals bisect each other, like they show. This is a very important slide. It's just a nice cheat sheet for you to find the information you need really quick.
Yep.
That way you're not digging all over the place in your notes. You can just find this page.
Basically, this one slide summarizes the last 2 presentations.
I mean, it's
puts it all together.
Parallelograms in a nutshell.
Yep.
So.
Yep. Okay, so what if we go to the coordinate plane? What if we graph one of these shapes? And so we have our 3 points, A, B, C, and D. It says to show that these coordinates create a parallelogram and state the theorem that allows that shows that. And so if we graph those points, so there's A at -3, 0. There's B at -3, 4, which is helpful because they're on a straight perpendicular line there at least. C is at 3, -1, and D is at 3, -5. And so those are straight up and down from each other as well. So if we draw the quadrilateral that goes between all 4 of these points, we get that. Okay. And now if we're going to try to prove that this is a parallelogram, we would need to either prove that, well, we'd need to use one of those 5 theorems that we had on that last slide. All right. And so if we show that 2 opposite sides are congruent and that 2 opposite sides are parallel, and so if we show that the vertical line on the left and the vertical line on the right are parallel to each other because they're both vertical, and then if we count the boxes, so 1, 2, 3, 4, each one is 4 units long, and so they're both 4 and they're parallel to each other, therefore that has to be a parallelogram because one pair of opposite sides is both parallel and congruent. Therefore that's a parallelogram. All right, anything else there?
Yeah, well, I mean, if you couldn't see that, or maybe you're looking at it, I mean, another way that maybe you could go about doing this, guys, if you weren't really sure, you can see that the 2 vertical pieces are parallel because the 2 vertical lines are parallel. I mean, that's just the way it is. But another way you could go about doing this would be those 2 that are on the diagonal there, just count the slopes, and if the slopes are the same, that might be another way that you could go about doing this if you weren't sure, was to just check and see if those 2 on the diagonal, if their slopes were identical, and they should be.
Yeah. If the slopes, remember, if slopes are equal, then they're parallel as well.
Yeah, I mean, that's just another way to go about doing it if you couldn't remember that rule.
So you'd know the vertical ones are parallel, you'd know the other ones are parallel because they have equal slopes, and so by the definition, both pairs would be
opposite sides are parallel, so it's parallelogram. So.
Yeah. All right. So we're going to be looking at some problems on how to show that quadrilaterals are parallelograms. So we'll see you guys in class.